All right, so this is going to be some good practice with going over problems, especially when they get more complicated, and how we're going to use these rules. So if you look at the very beginning of this handout, I'm actually not going over this part right here, but this is something you guys can do, which is hopefully really straightforward. You can see your A, B, C, D, and E, and determine what the angle relationship is. That's where you put for reason. So it might be angles on a line would be one of these, and you just write that down. Or vertical angles. You'd write that down as your reason. And then you can just put the angle measure. These are the very straightforward types of problems. And you will have problems like this on your test when we get to that. So generally speaking, what I'm going to be looking for is going to be the angle relationship that you notice. And I might even look for the equation that you set up as a result. And then the answer. What is your x value going to be as a result? So I'm going to skip over this. We're not going to do these. Right here, just for these types of problems, again, it starts off very straightforward on this handout. So you should be able to do these types of problems. And if we just look at the first one real quick, because we already did one very similar to this just a few minutes ago. So we see problem number 1. What is this angle relationship? Yeah. Oh, I thought you were raising your hand, but if you know, you can say.
I know it.
Linear pairs. All right, this is a linear pair, so I'm going to want you guys to write that down somewhere. Where you write it is fine. You know, it's up to you. But I'm just going to write these down. And now I need to set up the equation to solve for a missing value. I know this one is not difficult. You could probably, a lot of you could do this in your head also, but write down the equation. So what is it going to look like?
144 minus 180.
Nope. It's going to be 144 plus A equals 180. So there it is. And you guys can solve from there and you get your answer. So set up your equation. Again, setting up the equation is the hardest part of this entire process. And once you've got the equation set up, the rest of it should just fall in line. Because then it's going to be using algebra. The algebra can get more complicated. If you've already looked at some of these other problems, you know that it's not just simple stuff like this. So I'm just going to skip over to the other side of the page. And we've got these problems, 4 and 5, which look a little bit more complicated. Probably still something I hope everyone feels like they could handle. But I have a feeling you guys want to look at problem number 5. If we're looking at 4 and 5... So problem number 5. Okay, what is the angle relationship for number 5?
91 plus 91 plus 91 plus 3g.
Okay, angles at a point. All right, so we got angles at a point, and remember the basic idea. If you're looking at our generic formula, hey guys, make sure you're paying attention. If you're looking at our generic formula that we saw yesterday when we were taking notes, we just had 3 angles going around a point. We said A plus B plus C equals 360. Well, we've got more than that. We need to add up all of these angles. So,
91 squared plus 3g.
we can't do that. But we can do, all right, let's just show this. So 91, here's just 91 right here, plus G. And I know there's a fast way of doing this. Plus 91 plus G and plus 91 plus G. So these are all of the angles that go around that circle, around that point. And all these added up will be 360 degrees. So again, once we got the equation, it's just combining like terms, solving for G. Let's combine like terms real quick. If we add up all the variables, what do we get? Well, if we add up all the number terms.
300 and...
Or, sorry.
Wait, no, 1...
273.
Okay, adding up all the number terms is going to be 273. Okay, guys. Adding up the variables will be
29.
3G.
21.
29 is 29.
You guys are impossible. Okay, now it's a very straightforward two-step equation. 3G plus 273 equals 360. We can solve that.
36.
Well, subtract that 273 from both sides, what do we get? Or it should be positive. 87. All right. Divide that by 3, what do we get? 29. Okay, guys, I want the side conversations to stop. All right. So again, this one might not be too terribly challenging, and maybe it is. Maybe it's not. Yes. Did you have a question?
Oh, yeah. Like, if you were to put, like, your 91 times 3 minus 3
Just a second.
divided by 3 in absolute value bars, would that work too?
Well, we wouldn't need absolute value on this.
Like, if you take your 91 times 3 minus 360 divided by 3, and since you would get a negative since you're subtracting a larger number and you had an absolute value bar, would that work too?
We should be subtracting the smaller number from the larger one. We're subtracting 273 from 360. So, like, once you see it in this equation right here, we've got 3 G angles, and 273 is all the numerical degrees added up. So when we subtract, we're subtracting 273 from the larger number. Okay, maybe we can look at that one more later. All right, guys. So these problems, however you feel about these problems, I bet these problems right here are the ones that you guys are a little bit more concerned about, where we've got y and x that are thrown in there, and we need to start solving for both of those values. So we can solve for these. There's nothing wrong with it. We can do this pretty easily. But remember, this goes back to an algebra idea. If you have two unknowns, here we have x and y are both unknown, you have to have two variables. Sorry, you have to have two equations. We already have two variables. We have to have two equations, which means we can't just find one angle relationship, solve it, and call it good. We have two equations we need in order to solve for our unknowns.
Would it be 85 plus 2x?
Well, we're looking at number 7 on the other side. So we can go ahead and flip this over.
Thanks, Randy.
All right, and this one certainly does look a little more challenging. So what I want you to do, first of all, I'll give you a heads up for all these problems. If there is a blank on any of the angles, like notice right here, this angle at the bottom, there's no information there. We don't need to use it. We're not going to fill that in with new information. We don't need to. So knowing that that information isn't needed, we're not doing angles at a point. Also, we're not going to be using angle addition postulate. That does come into play from time to time, but it's not very often. When that comes up, I'll make sure to point that out for you guys. But basically, I'm telling you, for this problem, you only have 3 options. You could have angles on a line, linear pairs, or vertical angles. And one of those you can rule out too. Which one can we not use?
On a line.
Angles on a line. That requires 3 or more angles adding up to 180. We don't have that in this diagram. Yeah, so basically we're limited to linear pairs and vertical angles. And we could use one or both of those. So which linear pairs do you think we might be able to use? Do you guys see any linear pairs in that diagram?
Yes, right?
Yeah, we've got 2 sets of linear pairs. Well, we have vertical angles as well. Okay, so let's look at this real quick. We have this line right here, AB. Do we have any linear pairs going along that line? Which angles? Y plus x and y minus x. Okay, so let's just look at those real quick. Right here we've got a linear pair. I'm going to do this all in red so we can kind of see the distinction between it. So where do I want to do this? Right up here at the top. I've got my linear pair. And what would my equation look like for that linear pair? What do we know linear pairs do? Yeah, they add up to 180. So go ahead.
Y.
2y.
Well, let's not worry about combining anything right now. Let's just write it out. Okay, we've got two angles. What's one of my angles?
Y plus x.
Y plus x. That's one of my angles. This one right here. What's the other angle? Y minus x. So that angle, y plus x, plus this angle, y minus x, will add up and get and equal what? 180. Okay, now this is the part, and this is why I wanted to go through this with you, is because this confuses a lot of people, at least at first, and hopefully only at the beginning. The fact that these are all expressions does not matter. We have two angles. One of them is y plus x, one of them is y minus x. These are two expressions, but they're two angles. We can add those together, and they have to equal 180. And you can hopefully see right now the benefit of setting it up like this. So we don't know what y or x equals, but let's go ahead and combine our like terms. So we're going to combine our y's together. What do we get? 2y. We're going to combine our x's together. What do we get? 0. Those x's cancel each other out. All right. Now, here's another thing, though. If they didn't cancel each other out, that would still be okay. But it works out really nicely this way, where they do cancel each other. Okay, so we've now got 2y equals 180. What does y equal? 90. There you go. We just solved for y. And at the end, we can go back and double check, make sure these numbers make sense. Because right now we're a little bit going on faith that we're doing this right. We don't have anything that's proving to us that it's 90 degrees.
We're doing it.
Okay, so now we need to come up with another linear equation. We need to come up with another equation in order to solve for the other value. Yeah, go ahead. Okay, well, yeah, there's different possibilities. So if you have an idea, you can say one.
So can you take like the 180 degrees divided by 3 so that you get 60 on both sides? Or, yeah. And then you take your 60 and divide it in half, so then your x is multiplying your 2x by your 30, which is 60, and then 120 on the other side.
Well, we're going to do it a different way. Okay, and you might have the right math in mind, but we need to be more specific. So yeah.
We can use the vertical angle that's in it, where y minus x is equal to 2x, and then we just solve for x.
There you go. Okay.
Or 90 minus x equals 2x.
Okay. So we're going to go ahead and do this. We're using vertical angles. There are other possibilities, but we got vertical angles right here. And vertical angles, how do we set up the equation for vertical angles?
The two equal.
The two angles are equal. So you got y minus x is one of my angles, has to equal 2 times x. And this would be kind of our stopping point if we didn't already know what y equaled. So let's go ahead and substitute that in. So now you have 90 minus x equals 2x. You guys with me on this? Okay, this green isn't showing up very well, so I'll try and darken that a bit. So 90 minus x equals 2x. Hopefully that's a little darker now. Okay, so you can go through and solve this. All right, so let's solve this equation real quick. We're going to go through this one together. We're going to go through a couple more together. So what do we do if we have 90 minus x equals 2x?
Subtract plus x.
Add x to both sides. So if I do that, then these cancel, and I've got 90 equals 3x, 90 equals 3x, and x equals what? 30. All right, there we go. There's our answer. Now, again, if we want to double check that, we can do it. But let me just come back to the idea that if we have two unknowns, x and y, we need to find two angle relationships. Here we had vertical angles and a linear pair. Now, we could have done this with two sets of linear pairs, because notice we also have this linear pair right here. We could have done that. We have some options, but we have to have two different angle relationships so that we can set up two different equations, and we can solve for two unknowns. All right, so that one might have been a little bit challenging, and I bet you guys have your eyes on number 9 down at the bottom.
Yep.
Okay, so let's look at number 9.
Will this be homework if we don't finish it here?
No. All right. So I want everyone just to take about a minute and look at number 9 and see if you can identify any angle relationships that are going to help us solve for x and y. I should mention at the beginning, we do not need to use these blank spaces right here and here, and we're not using angle addition postulate. So I just narrowed it down to 3 possibilities for you. Okay, so anyone willing, share what angle relationships you're able to find. Go ahead, Chris.
Vertical angles and linear pair.
Okay, vertical angles for sure. Which ones are vertical angles?
3x plus 6 and y.
3x plus 6 and y. Let's just write this one down first, and then we'll worry about the other one. So we do have vertical angles right there. Tell me what the equation might be.
3x plus 6 equals y.
There it is. 3x plus 6 equals y. Now, you look at that. We don't have enough information to say anything beyond that. It's kind of a stopping point for now. But, like I was saying, even if we don't have things cancel out, we're okay. We're still going to be able to solve for x and for y. What other angle relationship? What do you have?
Vertical angles, and doing that I got x minus 11 plus 3x plus 6 plus x.
Okay, I'm going to stop you there because we're not going to need to use vertical angles anymore. We have an easier way of solving this rather than setting up as angles on a line. Okay, where are the angles on a line? What's that?
The y,
On top of it and on the bottom.
10, yeah.
Okay, it's
X minus 10, y, x minus 11.
there it is. We've got angles on a line right here. And notice I'm actually writing out what angle relationship I'm using. This is going to be the kind of stuff you're going to do on your test. You're going to need to say what angle relationship justifies this. Well, this is angles on a line, and we know that all 3 of those angles are going to what? They're going to all add up to 180. So we can write that down. We have x minus 10. We've got y, and we've got x minus 11. And these all add up to 180. 2 equations, 2 unknowns, 2 angle relationships, that's all we need. The rest of this is just algebra. So at this point, we could get rid of that diagram and we don't need it anymore. All right, so what can we do if we have those 2 equations?
Combine like terms.
Combine like terms, yeah, we will do that. Before we combine like terms, let's focus on that angles on a line. What can we do there? So this green equation. What's that?
You can replace y with 3x plus 6.
There we go. We're going to do some substitution. I'm going to take that. In my other equation, I've got 3x plus 6 equals y. So I'm just going to take that 3x plus 6 and replace it. All right. So I'll just show that real quick. 3x plus 6 is going to get replaced right here. And now I'll go ahead and write my same equation. X minus 10 plus 3x plus 6 plus 11 minus, or x minus 11 equals 180. So now I think is a time where we should combine like terms. Now we have all x's and numbers. That's going to make this all work out. Okay, so add up all the x's, what do you get? 5x. Add up all the numbers, what do you get? Close. Negative 15. So minus 15. And that still equals 180. We haven't done anything to the right side. So we just reduced all this down to a very simple equation, two-step equation we can solve. Add 15 to both sides. What do we get?
195.
Okay. All right, so 5x equals 195. Divide that by 5. What do we get?
A big number. 39.
Okay. We get 39.
I like my answer more. A big number.
Big is relative. Okay. So now that we know what x is, how do we solve for y?
Substitute and plug and shower.
Substitute that x back into...
3x plus 6 equals y, so 3...
Okay, all right. So now, we just... Okay, guys, settle down.
No.
We just solved for 39, or for x, which is 39. We can just substitute that right back in. So now I've got 3 times 39 plus 6 equals y. With your calculator, yeah, with your calculator, it shouldn't take you more than 10 seconds to do that. You guys checked out calculators at the beginning of the year. You need to have those, or else you're going to have to do a bunch of math by hand. So 123.
Your voice just cracked.
Good. Good for you. Okay. So there we go. All right. I wanted to look at one more with you guys because there's one more that a lot of people have questions on. I'm not going to go through the whole thing. I'm just going to set up a couple of equations. You guys can do the algebra. All right. But there you go. You've got to set up as many equations as you have unknowns. So we're going to skip over to number 3 on the next page. And what I want you guys to do is take about 30 seconds, and I want everyone to do this. I want you guys to look at this and see if you can identify what angle relationships we're going to use here. All right, so what angle relationships were you able to find in this diagram?
Linear pair.
We got a linear pair. Where is it?
5x plus 25.
And?
2x minus 5.
So that right there makes a linear pair. Two angles that are along a line. So we're just going to do this pretty quickly. That's a linear pair. Set up your equation for that. What does it look like? Well, let's not combine yet. Let's just write it.
5x plus 45.
Okay. Okay, guys. Make sure you're following along. 5x plus 45 plus 3x minus 25. Those are our two angles right here. And that equals 180. Okay. Now that's... Okay, guys, stop the side conversations. That is one of our equations. We can actually get our x value from that one equation. So it works out. There's no y's there. What is the other angle relationship we're going to need? What's that? We won't need to use angles at a point. We're not going to use vertical here because that would require a little more complexity. Angles on a line. I should point out, and this is one thing that does happen, angle y right here is not vertical with the 5x plus 45. If it was, that would make it really easy. But this line right here that's coming off to the right and up, there's no other side to that over here. So we don't actually have real vertical angles in this diagram except right here. But there's an easier way than setting vertical angles and then doing angles at a point, because that would be what we have to do. Okay, so we are going to do angles on a line, which is basically just these three angles right here. All right, so if we see those angles on a line, we can come up with an equation for that. What's it going to be? 2x minus 5 plus 3x minus 25. All right, so when we add all those up, we get what?
180.
180. All right, again, this is the hard part of the problem. The algebra should be the easy part. So we have these three angles right here, y, 2x minus 5, and 3x minus 25, that we add together to give us 180 degrees. So I hope that there's a little bit more clarity. We're going to work on this more tomorrow because you don't have enough time probably to get through all of it.
Thank God.
Okay, so we'll look at this more tomorrow, but also make sure you bring note cards tomorrow. We will use those. I had you buy those, but I don't know how many people actually did.